Students, in today's class we will study about this series LCR circuit. Okay, we have done many circuits in your class. Okay, if you just go back to the previous videos, we have done many circuits and the basic concepts of the circuit we have cleared in the offline theory class. Today this is your last circuit that I will do, that is your LCR circuit. First let us put that circuit diagram for this series LCR circuit. I will explain the circuit diagram, don't worry. This is your L part, this is your C part, this is your R part. That means your inductance, this is the capacitance, and this is your resistance R. Alright? Yes. So, and this is your alternating voltage, that is V, that is written here. So now students, as usually the general way we move ahead with the derivation, that is the alternating voltage applied. That means I'm talking about this part, that is alternating voltage applied to the circuit is what? The usual equation that we write, that is V equals to V naught sine omega t, isn't it? This is your equation number 1. Alright. So yes, so alternating voltage that we have seen for this circuit. Now students, if the instantaneous change in the current in the circuit be di, that means instantaneous change in the circuit, let us write it by di. Okay, then obviously since there is a change in the circuit, change in the current in the circuit, so obviously some EMF will be induced here. Okay, so what will be the EMF induced here? I'm just writing, its value will be equal to minus L di by dt, that is your induced EMF in this particular inductor, isn't it? That means here, okay, since you are having this inductor only, we are getting the EMF that is induced in this particular inductor. Okay, when, what is that condition? If there is instantaneous change in a current in the circuit B di, then only we'll get this induced EMF. If you just go back to the concept of this induced EMF, then you can able to see this. Okay, now on the other hand, if Q be the instantaneous charge stored in the capacitor, so obviously some EMF in the opposite EMF will be generated in this particular circuit, isn't it? So what will be that value of this opposite EMF? I'm writing here, this was your induced EMF, and here you are getting opposite EMF. What is that value? Which is equal to minus Q by C. Alright, okay. Now students, as usually we move, that is the effective voltage in the circuit, what its value will be. Okay, that means since you are having both these drops here, that means both these EMFs, that is here you are getting this induced EMF for this inductor, and here you are getting for this due to the charge, that is you are getting the opposite EMF. So what will be the net? Due to these drops there will be some effect in the voltage. Okay, so what will be the net voltage applied in the circuit? Okay, that means the final after reduction of all these two EMFs. So that I am writing it by VE, the usual way we write, is equal to V naught sine omega t minus L di by dt minus Q by C. That is the summation of all these voltages is your net effective drop, isn't it? Now let's move to the Ohm's law. Ohm's law is what? V equals to IR. That means here the effective voltage in the circuit will be equals to IR. So let's write that. That is V naught sine omega t minus L di by dt minus Q by C equals to your IR, isn't it? This I'm writing by the Ohm's law. Okay. So I'm just now in this particular next step I will just arrange it mathematically, then you can understand. Let me write it, then I will explain. Okay. What I did, students, I've just taken all these L di by dt plus Ri plus Q by C in one side of the equation, and I've just written this V naught sine omega t in the other side. That means keeping this alone, all other terms should be shifted in any of the two sides. Okay. So like the usual way, let us consider the value of Q as Q naught sine omega t plus alpha. Okay. So from this value of Q, I can able to get value of what? The current. What is that value of that current? To find it out, it's your dq by dt. That means I'm writing here I equals to dq by dt. That means I have to differentiate this Q's equation with respect to t for one time. Okay. So what will you get? Omega Q naught. Sign will change to cos omega t plus alpha. Clear? Yes. Now students, from this part, let's differentiate this particular equation of y again with respect to t. That means in what we are doing, in short, we are just differentiating this value of q with respect to t for two times. Okay. So let's write it. That is di by dt. All these are you have done in the maths class, so I'm not repeating the differentiation part. Minus omega square q naught sine within bracket omega t plus alpha. Clear? Okay. Now students, let us number the equations that we have written till so far. Let's write this particular equation as equation 2, and the first equation on top that I've written as equation number 1. Alright. Now students, putting these values, that means putting all these values that we have calculated here in your equation number 2, let's see what we will get. Minus omega square